Hi, everybody. This is Peter B. Parker here to help you guys prepare for your next test. I'm also here along with Spider Cat. Say hello, Spider Cat. Oh, Spider Cat. Ooh, you are purring already, aren't you, Spider Cat? So nice. Say hello, though. Oh, you say hello? Yes, yes. Oh, you're so cute. Oh, so cute. So cute. What? Oh, I'm getting a little weird. Okay, I'll stop, Spider Cat. Okay. All right. So we're here today to help you guys prepare for your next test. And so let's get started. We have a question here that says determine if the ordered pair satisfies the inequality. So how would we go about doing this? Well, it's easy enough. All you have to do is you look at the question, and we know that the first value, the x component, is -4, and the y component is 4. Okay, so all I have to do is substitute the values in. So x is -4 plus, you know what? Let's color code it. Let's get fancy here. Let's say y. Let's make y blue. So it'll be -4 plus 4. And then you know what? We'll go back to red just for fun. You know what? Let's just go black. Let's go crazy. There we go. Super color coordinated, maybe a little too much, is greater than -3. So we would solve this and see if what it speaks of is true. And so if I solve this, -4 plus 4 is 0, and 0 is greater than -3. Now, is 0 greater than -3? Well, clearly, you would rather have no money than be in debt, right? So that is actually true. So the answer here is determine if the ordered pair satisfies the inequality. It absolutely does. The answer is yes. And we're ready to move on. So let's just do that. Number 2. All right, so it's asking us to graph the inequality. So I would hope that y'all would stop for a second and ponder, what format do I need to make this in order to solve this inequality? And the format that we need to put it in is, you guessed it, y equals mx plus b. When I say y equals mx plus b, I am speaking loosely because it's not actually y equals, it's an inequality. But it's of the format y equals mx plus b, where m is the slope and b is the y-intercept. And so if I give you x minus y is greater than -6, let's just write that here, x minus y is greater than -6, we need to get y by itself. So what would be my first move? Well, obviously, the first move is that we need to move x. So how would we go about moving x? Would I add x? Would I subtract x? Would I divide by x? What would I do? Well, one thing to remember is that there's a positive x, and so we want to do the opposite. And the opposite of adding is what? Well, the opposite of adding is subtraction. Oh, 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 Spider Kitty was very excited about that. We know the opposite of addition is subtraction. Oh, you're so cute, Spider Kitty. Sorry. Okay, let's continue. So we're going to subtract x from both sides, and we're going to have -y is greater than -x minus 6, and let's continue. And so now we got to get rid of the negative sign. So how do we get rid of the negative sign? Well, remember, this is actually saying -1 times y. So the opposite of multiplication is division. So I'm going to go ahead and divide through by -1. Okay. So when I divide through by -1, I'm going to just write over all of this. I'm going to be left with y is greater than, now negative divided by negative is a positive x. Negative divided by negative is a positive, so I know I'm writing over things, but I'm going to get y is greater than x plus 6. What what is that, Spider Kitty? Why are you doing this. Oh, your ears fell down. Why, Spider Kitty? What's wrong? Why do you not like that? What's wrong with what I did? Whoa, he's very angry. Why? Oh, silly me. I know why you're upset, Spider Kitty. Spider Kitty's upset because I forgot something very, very, very important. And what's very, very important? When you divide by a negative, you have to flip the inequality. So we know now that it's going to be y is less than x plus 6. And remember what we said here, which is if it's eating x, we can make ourselves like a plane or like a flying spider maybe. And we know that if we tilt wherever we tilt the line, our head is above and our body is below. And if it eats x, we're going after our body or our torso. And if it eats y, we're going after our head. So we know whatever the solution to this is, we know that we're going to shade below. So one of the nice things to do is if we're shading below, A is going to be wrong because this is above, like tilt this way, or actually I guess it's tilting this way. My head is above, and that would be this region right here, right? Right, and that would be no bueno. This C for the same reason. Make sure, yeah, like that. Sorry, I'm tilted a different way. That would still be above, and that would be no bueno, right? And so we're left with B and D. So we have to decide if it's B and D. So how do I decide about this? Well, we're going to rely upon some of the skills we've learned before, which is this is a positive slope. And we know if the slope is positive, then we got to do what? We got to go up, right? We're going up the mountain. We're not going down. So we're swinging up, right? So that makes sense with D, right? B makes 0 sense at all. Now, we can confirm this in a lot of different ways. One way is that we can say, hey, if I'm not certain between B and D, I can take a point that I know that is on D, but not B. So I can easily say, let's say up here, well, we'll say something like here, we know that if this is 10 and this is 10, we know the point 10, 10 is safe. So let's look at what happens at 10, 10. So if I plug in 10 minus 10, I get 0, which is greater than negative 6. That is true. And so what does that tell me? That tells me that this is a potential correct answer, which means that that if the B has to be wrong because it doesn't have a point there with 10, 10 in there. And you, by the way, I just picked 10, 10 because it was obvious, right? It was obviously not here. And while in D, it's completely obvious, okay? You could have picked 9, 9. You could have picked whatever you want, okay? As long as you know it's an obvious point. Okay, so remember that. When you're working through this, even if you have no clue how to solve the problems, you can plug in points and figure out what the correct answer is. Let's move on. So the next one, number 3, is 5x plus y is less than or equal to 5. So hopefully you're like, oh, this isn't too bad. We know that in the previous one, it's the same thing. We just got to get y by itself. In fact, I think it's actually going to be easier. So let's see here. Let me rewrite this. We got 5x plus y is less than or equal to 5. And so just like before, the goal is to get y by itself. So here it's really easy. We're just going to subtract by 5x. And when we do that, we're going to end up getting negative 5x plus 5, which really is just, we don't put the negative 5x and the 5 together. And of course, we're not going to put those together because they're not like terms. All right. And so now we're just going to solve. So this one, when we solve, let's look at our answer choices real fast. Okay. So we know a couple of things here. Let's start with this. We know that it's negative 5, right? So if it's negative 5, well, let me back it up a little bit. If we're going to do this legitimately, we should go after the b first, which is this 5. So we know that the graph is always going to start at 5. So we can see if anything it doesn't have a 5. Everything has a 5, but we know that's our starting point. That's what b is. We know the slope is -5, so -5/1, which means I'm rising -5, which means I'm dropping 5. So if it's here, it's going to drop 5, and it's going to run 1. A is clearly wrong. Okay. If we look at B, we drop 5, we go over 1. This seems to be okay. Let's look at C. We drop, that's going up. That can't be right. And D, we drop 5, go over, this is going up. That doesn't make sense. So just by doing that, we already know the answer has to be B. And we can confirm this further. We said if it eats X, we shade below. So notice we're shading below. Again, if it helps, make yourself into a plane. Your torso here, because we're eating X, is what you're shading, right? So if we're here, right, it's our torso that we're shading here, right? I'm drawing a torso here. This is the body right here. Okay. All right. Okay. So hopefully that makes sense. And let's move on. All right. So here's an interesting one because we only have X. So what could we do if it's only X? Well, we know that X is greater than 3. And we ask ourselves, well, what is an X graph? Well, we know that an X graph means all of our X values are the same. So that means, if we're looking here, that means we can just plot some points like 3, 0, 3, 6, maybe I'll go 3, -10. And we can see that if we connected the dots, right? If we connected the dots, we would have a line going up and down, right? The line would be going up and down. So what else can we do here? Oh, what's that? What's that, Spider Kitty? Why are you upset again? Spider Kitty, you keep losing your ears. Oh my goodness. I want you to be able to hear. What's going on, Spider Kitty? Spider Kitty, you look a little angry. What's going on? Oh, I know why Spider Kitty is angry. I drew a straight line, and it really should have been a dash line. Is that right, Spider Kitty? Is that why you're upset? Ah. Thanks, Spider Kitty. Spider Kitty's always here to help make sure that I'm doing things correctly. So let's continue here. So what did I do wrong? This should not be a solid line. Remember, we said if it has a line, you draw a line. But if it doesn't have a line, then it's going to be a dash. So this one is actually going to be a dash. Okay. In addition, it says that x is greater than 3. So if x is greater than 3, what values are greater than 3? Well, that would clearly be values like 4, 5, 6, 7, right? These would be values on the right side, okay? So this means that the answer here has to be, the only thing that makes sense is B, okay? Some other things here that can help you out. Hoivux is the traditional way that a lot of people learn this. This means that you have a horizontal line. It has a 0 slope. And it's a y equals graph. V means it's a vertical. You have an undefined slope. And it's an x equals graph, right? So that's hoi h for horizontal, O for 0 slope, y equals, okay? V for vertical, U for undefined, and X for x equals graph. In addition here, if you struggle with the concept of horizontal versus vertical, like what does horizontal mean? Just remember that H, right, has a horizontal line like the horizon, if that makes sense. And then on the other one, I like to think vertical, it's like an arrow pointing down. So that means it's going up and down. So I hope that makes sense. Those are some little things, little tidbits of ways to remember this. And let's go on. So in number 5, so what's interesting in number 5 is they don't have a y-intercept here. But we know that when that is the case, there really still is a number there. Just because it's not written doesn't mean it doesn't exist. It does. That number is 0. So we know that the y-intercept is 0. We know it's -2, which means I drop 2 and I go over 1. So it's going to look something like this. Something like so. What is it? What is it? Spider Kitty, was that a meow of being sad? Or was that happiness? Oh, it was happiness, Spider Kitty. Yes. Spider Kitty's very happy because Spider Kitty wanted me to know, to remind me that because there's a line here, this is a line. Okay? So we're in good shape here. Now, if it's a y equals graph, okay, then, I'm sorry, y equals graph because I'm eating y is what I'm referring to. It's eating y. That means I'm going to shade above. Again, we're tilted like so, and so we're going to be eating above. So I'm there eating above. I'm a little hungry, actually. Okay. Is that basically it? I think so. Let's look at our answer choices. So I love the fact that just by realizing that this isn't a solid line, I can get rid of B and C because they're dash lines, right? Now with A and D, we got to look at the slopes. We got to be careful with the slopes. I think it's going to be A, -2 over 1. Let's see here. If we go down 1, 2 over 1, it looks like it's touching. Let's see here. If this one goes down 1, 2 over 1, it looks like it's not touching. Boom. D is wrong and A is correct. Hopefully that makes sense. I think we're okay. Let's move on. Okay, so we're done with the graphing part. We're done with solving graphs. We're going to move on now to figuring out how to solve systems of equations. And the first part, very similar to the very first question here, is, well, give you an ordered pair. Is that a solution? So remember back here, we did a nice job of making a color combination of x and y, and we're going to do the same thing over here. We're going to say that x is -3 and y is 6, okay? And we're just going to plug it into both equations and see what happens. So if I plug it into the first one, it's going to be -3 plus 6 equals 3, okay? We're going to do the same thing on the other one. We're going to do -3 minus 6 equals, sorry, I wish I could go faster here, -9. So we can see here, we just substituted into this equation. Let's see if both of these are true. -3 plus 6, yes, that is 3. -3 minus 6, yes, that is -9. So that is the answer. And of course, we can always solve these problems by just doing just that. We can always just substitute in values and see if it works. And clearly it does. All right, cool beans. Let's move on. All right, number 7. So it's asking us to solve, and it says solve by substitution, but really you can solve whichever way makes you happy. Substitution here really does make sense to use because y is equal to -2x. So if you have y already isolated, it makes sense that, hey, it's pretty easy to take this y value and plug it in for the other one. So I'm going to go ahead and do that. We're going to get x plus -2x equals -3. So notice I took the bottom equation and I substituted into the top one. And then we're just going to solve. So the nice thing about this is that we can solve this very easily because everything is like terms. So we just combine like terms. X plus -2x is -x equals -3. And then we can easily divide through by -1. So x is 3. And the really nice thing is that if I know x is 3, I can substitute that back in very easily into the second equation, which is now just substituting back in 3. So y is going to be negative 6. So if x is 3, y is negative 6. Boom, there's my answer. Now, interest in time, I'm just going to go ahead and move on to the next question. I have the answer key, so I kind of checked already and saw that that was the answer. But on your test, you may want to take both these values and substitute it. And you know what? It's actually really easy to plug it in. It's so easy. In fact, I'm actually going to do it. I'm not going to be lazy here. So x is 3, y is negative 6. Notice 3 minus 6 is negative 3. And then, of course, I plugged negative 3 into the bottom equation already. Negative 2 times 3 is 6. So, oh, I think Spider Kitty was trying to tell me that he's really proud of me. Oh, you proud of me, Spider Kitty? Oh, Spider Kitty, you're the mother kitty, Spider Kitty. Spider Kitty, what was that? Oh, Spider Kitty doesn't like when I'm too affectionate. My bad, Spider Kitty. Okay, let's move on. All right. What's next? All right, so let's look at the next question. So then the next question is y equals 3x plus 2. The bottom one is 2x plus y equals 2. And so what are we going to do here? Well, clearly, if y is already by itself, it's easy enough to just take this y value equation and substitute it into the bottom one. So we're going to get 2x plus 3x plus 2 equals 2. And let me do this to make it a little clearer. I'm going to write the original one in black, and then what we substitute we'll put in red. Let me just erase this and write 2 again. Okay. All right, so I think I equal, and then we're in good shape, okay? So you can see here again, I want to stress, y equals 3x plus 2, so then the y value becomes 3x plus 2. Okay, again, why do we do this? Why do we have to do this? Is because you can't solve an equation unless all the variables are in terms of the same letter, in this case, x. Now that they are, we're just going to combine like terms. So we have a 2x and a 3x. Put those together, you get a 5x. So we have 5x plus 2 equals 2. And I'm going to put like terms again together, but they're on the opposite side. So I have to subtract 2. And this is going to give me 5x equals 0. And then to finish off this bad boy, we're just going to divide through by 5. Don't panic. X is just 0. Cool beans. Now, one thing you can notice here is that if you look at it, you can see that based upon the work we've done thus far, the only answer choice that makes sense is B, because the x value is 0. Okay? But should I just be like, hey, that's cool. That's my answer. I can stop here. What's that, Spider Kitty? Spider Kitty. Spider Kitty. He lost his ears. He lost his ears. He's so upset over what I just did. He lost his ears. That's crazy. Okay, we won't give you your ears back. Your ears back? No, I lost my pen. Every time he's losing something. All right. Why do you all think Spider Kitty is so upset? Look at Spider Kitty. He's so cute. He's so good, Spider Kitty. Okay. Spider Kitty's upset over what? The fact that I'm being lazy, right? It doesn't take a lot of effort to just take x, which is 0, right? Plug it back in. Y equals 3 times 0 plus 2. So this clearly gives me 3 times 0. I mean, look at this. 3 times 0. What's 3 times 0? Y'all know 3 times 0 is 0. Plus 2 is what? Is 2. Okay? That took what? That took 30 seconds, and even then, I'm saying too much, right? Super easy, super simple. Don't get lazy. Work it out completely. See that it's right. In fact, even once we're done, let's plug it back into the second equation. Let's see if it works. So if x is 0, this goes away. And y is 2, so 2 equals 2. Clearly, That's the correct answer, okay? So don't get lazy, work your way through, and you'll get the answer, all right? And then Spider Kitty won't be angry. Right, Spider Kitty? You won't be angry. You're so cool, Kitty. All right, sorry about that. Okay, so let's look at this one now. Now, this is interesting because we have both of these equations with isolated variables. So we can have y here that's isolated, and here we have x. So it's your choice. It's your world. Spiders are just living in it. So what we're going to do here is we're going to take this y value and we're going to plug it in here. I just looked at the top one, said I'm going to plug the top one into the bottom one. If you rather reverse that, that's up to you. And something very interesting is going to happen here. Okay, so when I'm solving this, we're going to get a very special case. So -3 plus 6 is +3, so I'm going to be left with x plus 3 equals x. Now, it may be already apparent to you that there's something very fishy going on here, and that these two things can't be equal. But let's say it's not that apparent still. Well, we can easily show that it actually is very apparent. Apparently like the word apparent. If we combine like terms, so if I subtract x from both sides to combine like terms, I'm going to end up getting 3 equals 0. Now, I hope that everyone realizes that 3 does not equal 0, right? So because 3 does not equal 0, what do we say about this? Well, all we can say about this is that there's no solution, right? There's no way that's going to be true. And we're good to go. So let's move on. So that's one of the main special cases. If you get something that doesn't make sense, it doesn't make sense. There's no solution. There's no value that can actually work for that. Awesome sauce. Let's move on. All right, so this is saying using the addition method, which by the way is the same thing as elimination. So how do we do the addition method? Well, I'm going to first do this. Let me rewrite this. This is going to be x plus y equals -5. The other one's going to be x minus y equals 9. And I already put a plus sign. I couldn't help myself. We're clearly going to have to add these together. So x plus x is what? X plus x is 2x. Y minus y, when they go away. And -5 plus 9 is 4. So the elimination or addition method says, hey, can we put the two equations together, cancel out a term, so that we're just left with what we need to solve the problem? And here, clearly, that's the case. We can easily do that. So the next move is we're going to divide through by 2 like a basic equation, and then we easily see that x is 2. And so if x is 2, what now? Well, it's just like the other methods, right? We just take that value of 2 and we plug it back into whatever equation makes us happy. Okay, I like the top one. You got negatives no matter what, but I think the top is a little cleaner when I get to play with the x values. So x is going to be 2 plus y equals -5. And then we're just going to solve that. So how do we go about solving this? Well, we're just going to subtract 2 from both sides. And y equals -7. So if x is 2, y is -7. And there's my answer, 2, -7. Okay. Don't want to upset Spider Kitty here. So what in addition I'm going to do is I'm going to take the values of x is 2, y is -7, and I'm going to substitute it back in and see if it's true. So notice 2 minus -7 is -5. And on the bottom one, you're going to be left with 2 minus -7. And negative, we know, makes a positive. So this all becomes a positive. So you're left with 2 plus 7, which is what? Obviously, 2 plus 7 is 9. And there's my answer. So very good. Let's keep going. All right. The next one. Now, when you're eliminating here, I kind of glossed over this because it was so apparent that y minus y would cancel out. That's the goal. You got to get stuff to cancel out. So what's going to be very easy to cancel out? We can't just directly add these together, because if you add them directly, x minus 5x is not going to cancel out x, and negative 7y plus negative 7y is not going to cancel out the 7y's. So what can we do? Well, what's really clear, I think, is we can multiply the bottom one, and you could do the top one as well. It doesn't really matter, by negative 1. Actually, I'm going to rewrite it down here. And all that happens when you do that, when you multiply by negative 1, is you change all the signs. And we want to change the signs. So now, when I put the two equations together, right, we're going to end up getting what? 1x plus 5x is 6x. Negative 7y plus 7y is going to cancel out. And 27 plus 9 is going to be 36. So you can see that the purpose of doing that was to cancel out the 7y's. They go away. You just got this simple equation. 6 times what is 36? 6 times 6 is 36. Okay. How do you finish it off? You take that 6, you plug it into whatever makes you happy, whatever equation makes you happy. I would advise you, when you're plugging in, plug into one of the original ones. And the reason why I say that most of the time, sometimes editing is so obvious that, and you make it a lot easier to fix at the end, that it's better that way. But in general, when you plug back into the original, it's a good idea. Because if you made a mistake, the mistake probably comes in the editing. So if I plug back into the original, it's less likely that if I make a mistake, I'm going to be able to catch it. Okay, so this is going to give me what? I'm going to get 6 minus 7. You know what? I want to do everything in one color. That's no good. So let's do 6 minus 7y equals 27. So again, in case you're curious, right? X is 6, so this x became 6. This x became 6. And why don't I just do this? Since I can drag, kind of don't like where that is. Let's just drag that down here. Okay. All right. So let's solve this. It's in terms of one variable. We can solve it. So what am I going to do here? Well, the first thing you want to do is always put things together. Can I sneeze? Sorry about that. So I'm going to subtract 6. And when I say put things together, I'm speaking loosely. What I really mean is I'm going to put my constants together. Constants are just numbers. So we'll subtract 6 from both sides. We'll get 21 here. This is going to be negative 7y. And then what do I do? Well, opposite of multiplication is division. So we'll divide through by negative 7. Watch those signs. This is going to give me negative 3. So 6 negative 3 is the answer. Notice I'm not content with just plugging in 6 negative 3. I'm going to check it. So with the top one, do I have to do a little work to do this? Yeah, but is it a lot? Nah, right? So if we solve it, 6 plus 21 equals 27. 27 is 27. Pretty straightforward. All right, let's do the next one. Negative 5 times 6 minus 7 times negative 3 equals negative 9. Let's see what happens. So I don't know why I suddenly decided to change colors, but you know. I get such, and that is going to give me negative 9 equals negative 9. And I know it did correctly. So real important, don't get lazy on the test, right? Substituting doesn't take a long time. I know I'm a superhero, so it's really easy for me. But even for y'all, it's really not going to take much time to actually solve it. So just solve it. Just solve it. All right. Let's move on. Okay. So the next one, now this is a very interesting situation because there's nothing about changing signs or just changing signs, maybe I should say, That's going to solve this, right? If I make x negative, you're not going to get rid of the x. And if you make y negative, you're not going to get rid of the y, right? We got to do something else. And what we need to do is we have to multiply through by a value that's going to get rid of, to make either x, the number in front, x, which is called the coefficient, match up either with x or with y. So you can pick whatever you want, but I think what's most obvious is to make the top equation, multiply the top equation by -3. And that is because if I do that, now -59 times -3 is not simple, but we can do that pretty. Can't read my handwriting. 5 times 3 is 15 plus 2 is 17. So that's -177. Um, the reason why we'd want to do that is because we can clearly see that by doing that, the x's are going to match up. So what are we going to have? I'm just going to rewrite it. -3x plus 21y equals -177. I don't know why that's bothering me. By the way, let me make I'm going to make a math aside. I know I'm scatterbrained right here, but that's okay. Easy way of doing this: 60 times 3 is 180. So 59 times 3, 59 is just one less. So if you're to have one, if 60 times 3 is easily 180, 59 times 3 is 59 is one less than 60. And we're doing that 3 times, so that makes sense to subtract 3 from that, which gives me 177, which means that that is correct. So what I'm really trying to show you here, and I think this is such an important idea, is there's a lot of approaches towards solving math problems. What you want to do is you want to pick the one that's the easiest to figure it out. But if you know multiple ways, if you take it from one direction, you can solve it, and you take it from another direction, you can solve it, and you get the same thing. I mean, that's like a really good indication that you're going to get the correct answer. Like even Spider Kitty and I, when we talk about math problems, isn't that right? Spider Kitty, Spider Kitty, so cute. You're so cute, Spider Kitty, so cute. Sorry, Spider Kitty don't like it when I'm too aggressive with it. Okay, my bad, Spider Kitty. But in all seriousness, Spider and Kitty and I, we work problems out all the time together, and we compare. And that's what you want to do. You want to make sure that you're doing things two different ways, or if it's like homework, maybe work on it together and see, hey, I did it this way, you did it that way. Compare, talk about it. Math doesn't have to be done in isolation. You can do it with a friend. Oh, Spider Kitty purring. Okay, let's keep going. So what did we get here? We got -3x plus 21y equals -177. The bottom equation is the same exact equation. So the bottom equation is 3x minus 8y equals -73. And so we will add these two together, and we're going to get -3x plus 3x goes away. That's the whole point. 21 minus 8 is going to be what? That's the same thing as 20 minus 7, which is 13. So 13y. And this is going to be 10. Carry the 1, 14, 15. Carry the 1, -250. That looks, don't look too pretty, but that's okay. Let's keep going. So we got to divide this through. All right. Let's divide this through by 13. And let's see what happens here. So 250, let's see, did I make a mistake here? Yeah, well, if I think I did, right? How do I know? So this is nice. How did I know I made a mistake here already from the beginning? Well, I know I made a mistake because if we look at all the answer choices, the y values are all positive. But when I'm solving this, my y value is negative. So I clearly made a mistake. Let's see what I did wrong here. Okay, so what did I do wrong? Well, what I did wrong here, let's see, what color do I want to use? Let's go with red. Red's traditional, right? So what did I do wrong? Well, what I did was I looked back at the entire problem from the beginning. This is what you do when you did something wrong. Really, a lot of times you can just scratch the whole problem and just start it all over again. Okay. But what I did wrong is I noticed in the very beginning, I distributed. And when I did 59 times 3, I was so into doing the math that I didn't pay attention to the fact that negative times a negative is a positive. And this is actually one of the mistakes that I always look out for, typically by uh, realizing that I should always pay attention to the signs first. So normally when I do stuff like this, I always put the sign first. So I go negative times a positive is a negative, negative times a negative is a positive, negative times a negative is a positive. And so I'm leaving this in here. I could easily edit this out, but I want to leave it in here because I want you to see just how easy it is, one, to make a mistake, and two, what to do once you make a mistake. And what are some things to look out for? Like, one of my flaws apparently is that I don't pay attention to signs. Maybe that's one of your flaws. Maybe you're better than me. Probably. Let's keep going. So what's going to happen here? So this is, now we're doing 177 minus 73, which is not going to be negative 250, right? So we're going to erase this because it's not negative 250. We're going to subtract 177 minus 73. This is going to give me 4. This is going to give me 0. This is going to give me 1. So now I'm going to do 13 into 104, which isn't nice, but it's doable. So let's do that. 104 divided by 13. So how many times does 13 go into 104? So what you can do here, a nice little trick here, is I don't know. I honestly don't know. I'm going to argue it's 8. Why? Well, I'm going to argue it's 8 because I know 8 times 3 is 24. And so that means these 4s will match up. And I think it's actually, I don't think, I know it's got to be pretty, right? Because of the answer choices. So let's do 24. 8 times 3 is 24. That means I'm going to carry my 2. 8 times 1 is 8 plus 2 is 10. And so now when I subtract, I get 8, which actually tells me that if I'm doing this right, C is probably going to be the answer. B and A are out, okay? But I'm not going to be lazy. Don't want to upset Spider Kitty. And we're going to take y equals 8, and we're going to plug it back in. What equation am I going to plug it back to? I can plug back into whatever I want. I personally think I should plug back into, you know what? I think the top equation is better. So let's go ahead and do that. Let me give myself a little space here. Let me rewrite the top equation because I'm going to scroll up and I'm going to lose it. So x minus 7y equals negative 59. We know y is 8. So we have 8. This is going to be 7. So we have x minus 7 times 8 equals negative 59. And we're going to solve it. So how do we go about solving this? Well, 7 times 8 is 56, so we probably should do that first. So let's do that. We're going to get negative 56. This is going to be negative 59. X minus 56 equals negative 59. Now we're going to go ahead and add 56 to both sides. And x is going to equal to negative 3. Now let's see, was that negative 3 up there? Oh, went too far. Negative 3. Yep, that's a great sign. So negative 3 comma 8 seems to be right. Again, this one, I know the answer is the case. Really interesting time. I'm going to keep going. Realized I've gone way long in this. So I appreciate y'all's patience, but let's keep going. Let's move on to the next one. Let's look at 13. So 13 looks really nasty, but it's really not. So all I need to do here is in the very beginning, get rid of the fractions. I'm going to multiply it through by 2. Actually, both of them have 1/2, so let's just multiply both equations by 2. So when I do this, I'm going to multiply through by 2. I'm going to end up getting x plus y equals -2. And the bottom one, it's going to be x minus y equals 12. We'll put these two together. And why am I putting them together? Because it's so obvious that we have y on top and y on the bottom. So y minus y gets 0. We're going to get 2x equals 10. So x is 5. And so with x equals 5, I'm going to take this value. I'm going to plug it back. Now here, most of the time I said plug back into the original, but here it really does. I'm going to double check to make sure that you did this math right. But it really does make sense to plug back into the edited equation. So we'll take x equals 5. We're going to plug it back in there. 5 plus y equals -2. Subtract 5. Y is -7. So there we have it. Y is -7. Okay, looks a little bit more like a -7. So that makes sense. It's also the only answer choice that really does make sense. Again, on the actual test, go ahead, plug in, solve. Again, I'm going way over in time, so I'm just going to keep going. Okay, number 14. All right, so here we can see everything's all over the place, right? You got options. You could divide through by 10, and that would give you a fraction. And I'm sorry, that would give you y by itself, and you could substitute that value back in. I'm hesitant to do that because of the fraction. You could hear my subconscious talking about the fraction, right? So what I'm going to do first, let's just rearrange the bottom one. So 10y equals 10 minus 4x. I'm just going to go ahead and add 4x to both sides. So 4x plus 10y equals 10. And I like that because I got my x's and my y's on the same side. This is what's called standard form. I also like this because then I can take the other equation, which I'm going to write below. It doesn't matter really what you put above, what you put below. We have that there. So now what I can do is I think it makes it really obvious once we do this that I can very easily multiply the bottom one by -2. And that's going to get this is going to change this to -4, which matches with that 4, and it's going to make my life easy in terms of solving that. So when I do this, I'm going to end up getting, I'm going to rewrite the top one, 4x plus 10y equals 10. The bottom one's going to become -4x minus 10y equals -10. Now, this is really interesting. Because if I put these together, I get 0 equals 0. Ah, what's interesting about that? What's interesting about that is that the left and the right match up. So remember earlier we had a situation, in that earlier situation, this one right here, we got 3 equals 0. We said that's no solution because that doesn't make sense. But 0, 0 makes sense. 0 does equal 0. So when we get this, which makes sense, then what that means that we have an infinite many solutions. Okay, don't worry about this other stuff. But you get an infinite many solutions. Why? Because if we plug in, right, what this is saying is it doesn't matter really what you plug in for x and y. When you solve it all the way, the left and the right are going to match up because your x's are always going to cancel out. Think about it. No matter if I plug in 2, 3, 157, these are always going to cancel out. And you're just going to get 0 equals 0. Doesn't matter. So when the left and the right match up, infinitely many solutions. Okay. And now to the very last one, which is number 15. So how do we approach number 15? Well, let's see here. How do we approach this? Wait a second. Oh, what's that, Spider Kitty? Spider Kitty wants something. What do you want, Spider Kitty? Oh, I'm so sorry, Spider Kitty. Hmm. 1 second, please. All right. Spider Kitty wanted us to both wear our masks for the last problem, so here we go. Okay, so how are we going to do this last one? Well, if we look at this, well, the first thing we want to kind of do is put everything together. So what I mean by that is we want to rewrite this as negative 6x. We want to move this, well, let me just write it. Negative 6x minus 45 equals 9y. I'm going to move, I want to move the 9y to be with the 9x, so I'm going to subtract 9y from both sides. And so I'm going to get 9x minus 9y minus 45 equals 0. Now, that looks a little crazy because we got 9x, 9y, and negative 45. But that's okay. I can easily just add 45 to both sides. So we'll go ahead and do that. So you have 9x minus 9y is 45. And then what's also really nice about this is, and this is a very advanced move, but we can see that all of these are divisible by 9. So if they're all divisible by 9, why don't we just divide through by 9? And so I have x minus y equals 5. Okay? So with that, there's a couple of ways of really I can approach this. You know, I'm looking at this right here. This is a simplified version of the one on top. And I originally wasn't good thinking about doing this via elimination. But to be honest with you, if I just add y back over, why don't I just take x, which is equal to 5 plus y, and we can just plug that back into the bottom one. So we're going to end up getting 6 times, what's my equation down here? 5 plus y? 5 plus y plus 7y equals negative 48. And then all I got to do is just solve that. So I'll just distribute this out. I'm going to get 30 plus 6y plus 7y equals negative 48. And we'll just keep solving it. So let's combine like terms. Negative 13y is negative 48 plus 30. We're going to put the y's together. I don't want to do that color. Let's do that one. So I'm going to subtract 30. And I'm getting a little tight here. We're going to get 13y equals negative 78. I'm going to divide through by 13. And y is going to equal to what? Well, let's think about here. Let me think here for a second. Well, if we want, let's just run through it. So we want an 8 here, right? So 6, maybe? 6? What? 6 times 3 is 18, right? So let's try that. Times 6, 6 times 3, that's 18. Carry the 1, that is 78. Okay, so 6 is the magic number. So this is going to be y is equal to negative 6. Take that value of y, plug it back in there. Where's my mouse? I've lost my mouse. Let's just do it with the hands. Okay. So if we plug that back in, 5 minus 6, back in for x, and x is negative 1. So x is negative 1, y is negative 6, negative 1, negative 6. That is answer choice A. And you could always plug them back in to check. Shh, don't tell anyone. I checked the answer, and it worked out right. So there we have it. So I hope that makes sense. I hope you guys are doing okay with this. I hope this review really helps you guys out. And if you got any questions, please let me know, and I will do my best to help you out and solve the problems. Otherwise, good luck. Make sure you review. Make sure you go back through these problems. and I'll see you when I see you. Bye-bye from Spider-Man. Where? Who am I forgetting? And also, bye-bye from Spider-Cat.